In this module, you are going to learn an important feature of Swift language, that is how to create and use classes in your program. I assume that you are good at object-oriented programming. I will focus mainly on the syntax and discuss the Swift implementations. Classes and structures in Swift have lots of similarities, so whatever you learned in the previous lesson applies to classes described in this lesson. I will begin with a trivial class definition. You declare a class in Swift with the class keyword. Here, we define a class called bank account. A class has the properties and methods just the way a structure does. Here, we declare a single property called balance amount of type float. As the name suggests, this holds the value of current balance in an instance of bank account class. The function withdraw takes one parameter of type float. The parameter name is the amount. The method body reduces the balance amount by the amount specified by the amount parameter and also prints a message to the user to this effect. The function deposit receives a parameter called amount of type float and adds this to the balance amount variable. The balance function returns the current value of the balance amount variable. Now, I will show you how to instantiate and use this class. We create a class instance by calling its initializer and assigning it to the variable called MarryAccount. Note that the type for MarryAccount variable is automatically inferred to be of type bank account. Next, we retrieve the value of the current balance by calling the balance method and print its value on the console. You may deposit some money in the account by calling its deposit method. You can verify the deposit by checking the balance amount one more time. To withdraw some money, you will call the withdraw method. Once again, the effect of this method is verified by printing the new balance on the console. So declaring and using classes is very much similar to using structures that you learned in the previous lesson. I shall now describe the differences in classes and structures. These are the four major differences between structure and class types. Classes support inheritance. I need not describe inheritance to you as all of you are developers who know object-oriented programming. Briefly, if you still want to know what is inheritance, then it is sufficient to say that inheritance allows a class to inherit the characteristics of another class. Typecasting allows you to check and interpret the type of a class instance at runtime. The deinitializers allow you to free up any resources that you may have acquired during the lifespan of a class instance. You may consider this equivalent to destructors in other languages. It is possible to create more than one reference to an instance of a class. Note that I mentioned it earlier that unlike structures, class instances are passed around by reference and not by value. Thus, a single instance may be referred by more than one reference variable. As you know, classes are of reference types. It is possible for two variables or constants to refer to the same class instance. Swift provides two identity operators to find out if two constants or variables refer to the same single instance of a class. Consider the code snippet shown here. We will create two instances of our bank account class. These two instances will refer to bank accounts of Mary and John respectively. We will also create a common reference to access any of these two bank accounts. These 4 lines of code create the two account instances and deposit some money in each account. We now create a reference variable that is set to refer to Mary's account. We now use one of the identity operators to check if the current account reference refers to John's account. As it does not refer to the John's account, we print an appropriate message to the user. Next, we check if the account reference currently refers to Mary's account. As this is true, we retrieve and print Mary's account balance. Note that these two identity operators cannot be applied to structure instances as structures are always value type. I shall now describe property observers. When a property value changes, the runtime calls two methods, willSet and didSet. I will illustrate the use of these methods with an example. Consider the definition of temperature sensor class shown here. We declare a variable called current temperature to hold the currently measured temperature. Whenever the value of this variable changes, the runtime will call the willSet method. The method receives a parameter with a value set to the new value that it is about to be copied into our current temperature variable. In the method body, we just let the user know the new value by printing it on the console. After setting the variable value, the runtime calls the didSet method. In this method, we check if the current temperature has raised by more than 10 degrees. Note that the old value constant is implicit and is provided by the compiler. We now print a warning message to the user of a sudden temperature rise. To use the temperature sensor class, we now use the above code. First, we create an instance of temperature sensor class. Note that the value of current temperature variable will be set to 0. Next, we set the current temperature to 10. This calls the willSet method and prints an appropriate message to the user. When we set the current temperature to 25, the condition in the didSet method is satisfied and the runtime prints the warning message to the user. This is the program output. Now, I shall discuss the most important feature of object-oriented programming, and that is the inheritance in classes. I shall illustrate how inheritance is implemented in Swift using an example code. Consider the definition of server class shown here. The server class defines two properties to keep track of its start and stop time. In the start function, we get the current system time and copy it to the start time variable. If you know Objective-C, you would know that the CF absolute time getCurrent is an Objective-C method. It just returns the current system time. Incidentally, this also shows that you can mix the Objective-C code with Swift code. I will discuss the integration of Objective-C code in Swift in advanced course. Likewise, the stop method records the current time and end time variable. We will now extend the functionality of this server class by creating a subclass called Tomcat Server. We indicate the subclassing by writing the name of the base class after the colon. In the Tomcat Server subclass, we write a function called start. As our superclass server has a method with the same name, you need to prefix the function definition with the override keyword. In the body of the function, we start our base server by calling the start method of the superclass. To call the superclass method, you need to use super keyword. As a matter of fact, you can also access the superclass properties and subscripts using this syntax of super dot. Likewise, we also write the overridden stop method. In its body, we call the superclass stop method. We now print the elapsed time. Note that both start and end time variables are properties of the superclass. It is not necessary to use super-dot notation to access the superclass properties, as there is no ambiguity in accessing those. To test the above classes, we use the code snippet shown here. We create an instance of Tomcat server. We start the server by calling its start method. This results in calling the superclass start method that records the current time in its start time property. To simulate the uptime of Tomcat server, we create a time delay in the program loop. Finally, we stop the server. When you run the program, you will see the output similar to this one. In most other languages, there is a base class from which all other classes are derived. In Swift, any class that does not inherit from another class becomes a base class. You may derive the additional classes from this base class. Thus, you may have many class hierarchies in your program code with no single root or base class. If you want to prevent subclassing, whether accidental or intentional, use final prefix in your variable, function, and class declarations. With this I close this course. As said in the beginning, I have attempted to give you a head start on Swift programming. I hope you enjoyed the course. Do send me your questions on the forum. I shall attempt to answer those in a reasonable period of time. I look forward to you taking my next course on advanced Swift programming. Hope you like this module. Over the past several years of iOS development, we have deployed many apps in the App Store. Like this course, many of these apps are free to download. Do visit the URL mentioned here to download and try out these apps. Thank you for supporting our development. Now, as you have completed this module, you will definitely like to look up other modules in this course. Do visit the above URL to get links to all other modules in this course.